Hi, 7-8, negative rational exponents. It's the exact same thing as 7-7 that we just did, except for one additional step. So we want to do that, and then I really just have three examples and then one kind of comment, one additional thing. But here, this first one, I have 256 to the negative 3/4. So we're going to start it out. The first two steps are the same as what we were doing yesterday. That if you do the fourth root first, it makes the numbers more manageable. And take that to the third power. So this here takes care of the 3 and the 4. The new thing is we have that negative in there. So we could take all this to the negative 1. If we multiplied all these exponents together, we'd end up back with our negative 3/4 power. So we know it's equal. So we start on the very inside, say, well, 256 to the 1/4, what to the 4th power is 256. So if you have that index card handy, you could flip over there and say, all right, that's going to be a 4. So that inside set of parentheses just simplifies to a 4, and then we still have 4 to the 3rd, and that to the negative 1. So 4 to the 3rd, we could jump to our third power column, and alright, that's going to be 64. So what's inside the parentheses simplifies to 64, and the only thing we have left is this negative 1 in the power. If you think back to earlier in the chapter, section 3, I think, that just means when you have a negative in the exponent, it's the reciprocal of the base. So here we have 64 over 1. So that 64 then is going to be moved down below. So we'd have a 64 to the 1st power now that's down below. And we need to put a 1 in the numerator just to kind of hold the place. It can't be a fraction without something on top. But it's not that this 1 moves. It's that the 64 goes down below and we need to have a 1 to hold the place. Other two examples are the same thing, so I'll try to jump through a little bit faster. What you might want to do is just do it on your own a second and then fast forward through the video, see if you can get the same answer as what I had. But we have 512 to the 1/3 power, that's squared, and then we have a negative 1 to take care of my negative. So what to the 3rd is 512, and we see right there it's going to be an 8. So the inside set of parentheses just simplifies to an 8. We still have 8 squared to the negative 1. 8 squared, you could look it up if you need to. That's 64. And that's to the negative 1. That's a little awkward. I have the same exact answer twice. And then 64 to the negative 1 is 1 over 64. It's a case of bad planning there, I suppose. This last one, that ought to give us something different. 125 to the negative 4/3. So have 125. You could do the cubed root of that. And chances are you're not going to be writing these out, at least after you've done a few. I know I don't when no one's looking. So what to the 3rd power is 125? It's a 5. You could look it up over here. That right there. So we still have 5 to the 4th, and that to the negative 1. So 5 to the 4th, you could look that up. It's going to be your 625. So we have a 625 to the negative 1, which means 1 over 625. So like I said, same thing as what you were doing in section 7, just one additional step. The last thing I want to mention is that we're going to get things like, I need a quick glance at my notes for this, x to the negative 3/2. So if you have x to the negative 3/2 equals 512. Well, maybe before I get to actually solving that, I'm going to try to build a case. So say you have the square root of x equals 5. Well, another way to write that is square root is 1/2 power. So we could say that's really either of those problems. When we had one like that, I said, well, what's the inverse of square rooting? And that's to square. That when you square, that undoes the square root, so we come up with x equals 25. Well, if you notice, that same thing works with the exponents. Because when we square both sides, here we have 1/2 times 2. That just gives us x to the 1st. When we combine those two by multiplication, equals 25. So if you look, we had a 1/2. We take that to the 2nd power, which for dramatic emphasis, I'll put that as a 2 over 1. Will that work for everything? If you have x to the negative 3/2, how do we get rid of it when it's a much more complex exponent? Well, just like 1/2, we took it to the reciprocal power. If we did that here, negative 2/3. You could grab a calculator if you don't trust me, but we multiply those two exponents if we're going to combine them, which then, multiplying fractions, you just multiply the numerators, multiply the denominators. So negative 3 times negative 2 gives us a positive 6 over 2 times 3 is 6, so we really just have a x to the 6 over 6, or x to the first power. So then that means the right side is just our x. And you could go through and say, well, what to the third is 5/12? I think that's the example we just had, right? 5/12 to the negative 2/3. So we know then that the answer would end up being 1 over 64. And that's all for this chapter.